Hello, everyone, and welcome to Open Observability Talks. I'm your host, Dotan Horovits, and here at Open Observability Talks, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you. Actually, I just came back from KubeCon North America in Atlanta. I even put on the T-shirt. For those on the video cast, let me show you this one. And as you can see from my KubeCon shirt, we celebrated 10 years to the CNCF. Really exciting stuff. I still remember, by the way, blogging when the CNCF was established a decade ago, and actually wrote a blog post now on this first decade and my own personal experience, also as a CNCF ambassador. So I'll share that on the show notes, and I'll share some major updates on the breaking news section at the end of this episode. So stick around with us. And with that, let's move on to today's episode. Generative AI is everywhere, right? Everyone these days builds some GenAI apps. But how do we monitor and observe these workflows? OpenTelemetry has been a prominent tool and a standard for observability. We've been covering it extensively here on the show. And recently, the OTel community has been aiming to expand its scope and cover the GenAI workloads with semantic conventions and with tools. One initiative is around creating semantic conventions for GenAI observability, and another is the OpenLLMetry open source project that extends OTel for this use case. In this episode, I invited Nir Gazit to tell us about these developments. Nir is the creator of the OpenLLMetry project and is also a member of the OpenTelemetry GenAI SIG. So, hey, Nir.
Hey, great to be here.
Thank you so much for joining me on this podcast. Where are you joining us from?
Tel Aviv, Israel.
Finally having someone on my time zone that makes it much easier to coordinate. Yes. And someone who knows what it feels like to have this heat at the end of November. So when the rest of the world is freezing cold.
Yes.
And you've been around data and AI for quite some time. Can you tell us about your background that led you for today?
I worked at Google for many years, built ML models for predicting user engagement and retention for kind of other Google products. I also worked at Fiverr for a couple of years. I was the chief architect there, where when I was there, we built, Fiverr's machine learning platform and data pipelines. And also my co-founder, who's, by the way, I'm not the sole creator of OpenLLMetry. I'm the co-creator together with Gal, my co-founder. He was also working with me at Fiverr, and he was the lead for everything that I mentioned before. He was the director of platform at Fiverr.
Amazing. And of course, today you mentioned co-founder Traceloop, your new venture today that is squarely in this area. So want to say a bit about that one?
Yeah. So Traceloop, we're a platform for monitoring and evaluations for GenAI specifically. And I think, and we started it, me and Gal, my co-founder, 2 years ago, kind of right when OpenAI released GPT-3, was November 2022. And we came, with our background from Fiverr, building with OpenTelemetry, and it felt natural for us to take OpenTelemetry to the kind of now emerging GenAI world.
Yeah, sounds good. And so I want to start, before even talking about technology or OpenTelemetry or anything else, we talk about observability. I think my audience definitely knows a thing or two about the classic, let's call it observability in IT systems. But maybe in the context of AI, what kind of observability needs are there for AI?
So it's a really interesting question. I think, first of all, there are kind of two types of observability that you need for AI. And this is kind of different than if you compare it to kind of classic observability. So let's say you have a database and you want to observe it. So you want to look at kind of metrics like latency, error rate, maybe kind of these like would be the basic things that you want to see when you observe a database. So if you go to AI, first of all, you have the same things, right? You want to look at latency, you want to see kind of slow calls you're making to an LLM. You want to look at error rates. But then you have this whole new world of different types of error that you cannot just observe just by looking at the metadata of the requests, right? So going back to the database example, you want to look at 500 errors and slow queries for your database. When looking at AI, you probably going to have a lot of AI calls that ended up successfully, but from an engineer perspective weren't successful at all because the AI hallucinated, the AI just returned the wrong answer, or I don't know, there was a jailbreak, a jailbreak attempt. So there's a lot of things that can go wrong with when you call an AI, even though by looking at the metadata, everything seems okay.
Yeah. So it's important point because obviously the typical things that we typically like red metrics, the golden signals and so on are applicable, but it's also important to realize the differences or the unique characteristics. You mentioned a few like hallucinations, like jailbreak attempts. I maybe even add other things like I don't know, bias detection. Ethical LLM is a big thing these days that people obviously want to monitor. Some of them you need to monitor to adhere to and conform to certain standards. So what do you see from the use cases both in your startup and in the community work are the main use cases that are, I would say, AI specific or specialties that come out in observability?
You mean use cases for AI or like
for observability? No, for observability for AI, but that they're not, as you said, the classic one, but rather ones that people might not think of, people that don't come from AI workflow. That hey, if someone wants to, from our listeners, want to take away here, and they're new to this field, be aware or at least pay extra attention in these areas that you want your observability there as well.
So I think everything that I mentioned before, you can kind of divide it into two types of metrics that you want to monitor. One is kind of the classic cost latency error rate. But then on the other hand, you have like quality metrics. So everything that we mentioned is kind of measuring the quality of the response. And the classic way for measuring quality, everything is super new, but like the way it became common for measuring quality for AI systems today is by using another AI, another LLM. So this is this so-called LLM as a judgment method where you take the response you've gotten from one LLM and then you use another LLM to judge that response and make sure that the response is correct. And this is kind of, this opens another set of metrics and techniques on how to do it accurately in a cost-sensitive way so that you don't go bankrupt just by monitoring your own AI system.
Sounds good. And I think it's worthwhile mentioning also, if you look at the flows, there are single stage, there are multi-stage LLM workflows. Maybe worth saying something about the complexity of what you said, because you said also layered LLMs.
Right. I think when you think about quality of AI, there's a lot of things that you can measure, right? You can look at the kind of your LLM workflow or agent as a black box. You just, okay, there's an input. The user has created the input and then the AI produced an output. Let's see if given that input, this is the output that I expect to get. Or is this input like the good one, the one the user to be able to send the AI? And then there are other methods to kind of go into the agent or the workflow and kind of make sure that everything inside was working correctly. You can, I like comparing it to testing, to like classic like classic testing for pieces of code that you write. So you have the black box testing, but then you can also have unit testing. So you can kind of, you have an agent, you can test each step the agent took separately. You can test, and you can also test kind of like the overall flow of the agent. So if you think about it, it may be that the agent took the right decision each time, the output was correct, but then the flow, the route that he took to get to that answer was really weird and it took it a really long time to get to that answer, and it took a lot of different kind of paths that you didn't expect to take. This is sometimes called agent trajectories. This is another, like the third thing that you want to test, monitor for an agent execution.
Yeah, and I think one of the things that you mentioned, because you sort of said correctly that there's the black box and the white box approach. I think the white box approach, we all know, again, from the traditional IT, so I'm not going into the traditional, but I'm saying specifically in AI, there comes another dimension that's the dimension of explainability, which becomes more and more important. And I think here is the white box gets extra important also for being able to then take the reasoning and report it back to either auditing purposes or to leadership or to regulatory reasons or whatnot, right?
Right. But then this goes all the way back to just we need to be able to log everything that's happening in your AI system, right? You need to kind of have a standard way to log all the prompts, all the completions, all the tool calling, every step along the way that the agent took to get to the answer that it got to at the end.
Yeah, so that's like sort of the multi-stage reasoning that when you get the visibility into this specific stage, you can at least try as much as possible. I know it's challenging and not trivial at all, but to try and provide some sort of explainability or reasoning, explain the reasoning to justify why these things happen. So and you mentioned also, you said tracing the thing, and I want this takes us maybe to the telemetry signal. So again, from my audience knows traditional observability, as maybe you call it. So we know the traces, logs, metrics, and other signals. Again, I want to put the hat of the specific AI needs. What would be the types of telemetry signals and usage of these signals in the case of AI observability?
So this is again where we diverge from classic observability. So again, going back to the database example, you usually don't really care about like the actual query, like the content of the query and everything that went between the database and your services. Or for example, if you look at OpenTelemetry, then the instrumentations for HTTP calls or instrumentations for database calls usually don't log the content of requests that are sent across your services. In AI, it becomes really important. First, because I want all the quality metrics that I mentioned before. This will be another layer on top of the data that we collect, that I want to collect. But also for, as you said, like I want to explain why the AI made the decision it did. There's a lot of regulatory requirements. Like in the EU right now, you have to log every prompt, every completion, everything that's went in and out of your AI system. So you need to do more. You can't just log the metadata of a certain kind of request. You need to log what was happening inside. So then if you're thinking about AI monitoring and you're thinking about the trace of AI monitoring, it's not just the different microservices that went and like how much time each one took to process that request. You also want to log the content of each request, like the prompts and the completions. And of course, then the metadata like tokens, number of tokens, latency, another kind of request metadata that you have. But the prompt and completion are really important, and they alone are enough to make everything much more complex when you think about how do I use OpenTelemetry to observe that.
Yeah, and I think we should definitely dive into that. So let's look again. Let's look at tracing. Okay, what's tracing AI? What does it mean to trace AI apps? Are we tracing prompts? Are we tracing the model behavior? What is a trace in the context of AI workflow?
So we're tracing everything that's happening on the client side. So we want to see tool calling. You want to see multiple prompts. You want to see completions. We want to see everything that went out to the model and every step that you took in response to what the model returned to you. So let's say you have an agent. So how do you operate an agent? You basically have a prompt which is the user question with some kind of context that you gave it, and then a couple of tools that the agent can call. And then you send it to the AI system, the LLM, and the LLM returns to you, hey, call this tool and pass it these parameters. We want to log this, right? We want to log the prompt. We want to log the request to call the tool with the arguments that the LLM asked us to call. Then we want to log the tool response. And then there's another LLM call to kind of, okay, this is what the tool responded to me. Now what should I do? And this kind of back and forth between the LLM until we get to the final answer is what will become the trace of the agent execution and contains everything that we want to log.
Interesting. And it's important to say that this is, as you said, it starts on the client side and to the server side. So here we see in IT that many times the trace focus, for example, just on the back end, or here it's very, very important that the context flows from the original API call from the client side to the server side and back, right?
Although when I say client side, I'm talking about your backend, right? I'm not talking. I think there's an interesting differentiation between your backend and, let's say, OpenAI's backend. So we have full visibility and want to log everything on your backend. Everything that I said is happening on your backend, but then I don't have any visibility into what's happening in OpenAI. It's a shame, I would love to get understanding of what's happening inside. Why, for example, and this is like a real story that happened to us. Why, when I upgraded to GPT-5, everything was just so much slower without changing anything on my end. I'm guessing it's something happening on their backend, but I have no visibility to that. So client side is my backend in this case.
You're calling to the backend of the LLM provider.
Yes, exactly.
Yeah, makes sense. And you touched before also on metrics. Again, metrics, we know them and their value from traditional observability. But what are the metrics that you find, or the best practices that you see around AI observability with regards to metrics?
So in this case, it's much more traditional, right? You want to see latency, you want to track cost, you want to track number of tokens, which is kind of similar to cost, and then you can also track things like time to first token if you have streaming requests. And I would say that kind of basically covers most of the metrics that you can extract from the LLM as is. Then by like applying some layer of processing, you can get the second layer of metrics, which I talked about before, all the quality metrics, right? These are also metrics that you want to log and look at. At the end of the day, you want to see like a Grafana dashboard which contains cost, latency, but then also accuracy and a hallucination rate or whatnot.
Yeah, makes sense. And you mentioned cost. I think this is something that I see day in and day out, that this becomes the most significant cost factor with the AI. The cost of tokens when you use, of course, the not your own models, but the models provided, and it suddenly all the infrastructure and the rest of the things become negligible when you look at it. So I think here, while we know it from IT, I think in AI, as you said, the amount of tokens, the cost, the associated with that becomes like really, really crucial for the leadership to monitor, right?
Exactly.
Yeah, makes sense. So that was a bit of a background because I think it's important. And actually, maybe before we go on the technology, the specifics, I think one more thing is that there are many concerns. Again, I think you touched it briefly, but I want to put the spotlight here because for those who don't know, it might not be intuitive. There are many concerns in AI that are different than classic cloud IT monitoring. We talked about tracing, but the amount, so the throughput that they'll get, or the amounts of invocations per second will not be as many, but the latency, on the other hand, we're not less sensitive to the latency of the call itself because the LLM takes factors, orders of magnitude longer. So can you tell us a bit how you see the difference of concerns between classic AI monitoring and observability and the AI ones?
Maybe it's a good time to talk a bit about OpenLLMetry and the project we started back in August 2023. So we knew about OpenTelemetry because of our days at Fiverr. I was helping implementing OpenTelemetry within Fiverr, which was great for us. And then when we went out and started Traceloop, we were looking for ways to observe AI systems, and we realized, okay, we should use OpenTelemetry, and we started building. There weren't any instrumentations for any of the models that were out there. OpenAI, I think Anthropic had a kind of a Claude 2 model, and maybe Bedrock has just started back then. And so we didn't have there weren't any OpenTelemetry instrumentations for these models, so we built them. And quickly enough, we discovered the issues. Okay, how do we log a prompt? So for us, okay, you want to log. Let's go back. Let's think about, okay, I'm creating a span that will represent a call to OpenAI. What do I want to log as an attribute to that span? So I want to log the model that I used, right? It makes sense. I want to log the number of tokens that it cost me. I want to log the cost maybe as well. I want to log other request parameters like I don't know, the service level that I required from OpenAI and other kind of request parameters that I'm sending to OpenAI. And then I also want to log the prompt, the system prompt, the user prompt, and the completion, the response I got from OpenAI. And the problem is these can get big. And with time, we got into bigger models with bigger context windows. So this means bigger prompts. And we wanted to log them as attribute on the span, right? Is the only thing that makes sense. The problem is that OpenTelemetry wasn't designed for big attributes. And so there was a challenge. Okay, how can we log that? And we made the decision of logging them on as an attribute, because then all the post-processing that I mentioned before can easily be done. The problem is that all the other backend observability system weren't designed to handle large attributes, because in their mind we're handling massive amount of volume of I don't know, requests and spans that are created in systems that handle millions and hundreds of millions of requests per second, and so I cannot process big attributes, because then I will just I won't be able to process that many spans a second. But if you look at AI systems, so you don't have that much scale. You have much less spans per second, just because each span takes much longer to complete, right? You call an OpenAI, it will take you a couple of seconds no matter what you do. So you have much less spans. Each span costs you much more, right? Each request to OpenAI costs much more than a request to Postgres. So by design, you're not making as many calls to an LLM as you would have made to a database. And so the scale is much lower, and then you may be able to make some compromises on the span size, because you have much more time to process each span. And so there were a lot of kind of discussions around, okay, how do we do that? And when I founded GenAI SIG back in was April 2024. April 2024, we got into these decisions. And then OpenAI came out with the first vision models. And then the discussion was so much more complex, because it's not just prompts that kind of, take 1 kilobyte, 2 kilobytes. Now we have images which can wait and up until 8 megabytes. So you have 8 megabytes of an image that you want to send on an attribute of a span. It doesn't make really much sense. So there were a lot of technical challenges that we need to kind of solve when thinking about how to observe AI systems in a way that will be useful for the end developer.
Makes sense. And you mentioned briefly, and I also mentioned in the opening, so you mentioned the SIG. So we'll talk a lot about the SIGs. Don't worry. SIG is a special interest group, for those who don't know. And there are several SIGs, special interest groups, under the OpenTelemetry project, one of which is the one that was fairly new one about the GenAI, generative AI in OTel, with the aim to define the semantic conventions. Don't worry, we'll dive into that. But I want to stay a bit with OpenLLMetry. So you talked about, first of all, the pains, and going back to my question about these concerns in AI that are different than classic monitoring. I think you brought it up just to summarize for our audience. There's several things. First of all, the throughput is, we don't talk about millions of invocations per second, because anyway it takes maybe even a few seconds for the LLM to respond. So this puts a very strict upper limit to how many about the throughput. So on the one hand, we talk about much lower throughput for traces. On the other hand, and also on the latency, obviously, because we're less in many systems, we're very sensitive on the latency. And as well as the instrumentation latency adding to it. Here, latency anyway, again, the invocations to the LLMs are slow themselves, so the rest of the things and all the optimizations around that become much more negligible. On the other hand, the payload size, the span attribute size, we talk about something much bigger, orders of magnitude bigger than what the traditional observability is, because of this context that you need to pass along with the call. So I think this is important, first of all, for the users to understand that on the one hand, it's OpenTelemetry. On the other hand, there are aspects that are very different that needs to be considered. Also, as end users, and also I think as background to understanding why we need all this brain power to think about tooling and about specifications and semantic conventions to accommodate or to adjust for these use cases. So I think this was very clear, and for those who are not living it day in and day out, I think it's very good to understand. Which brings us to, as you said, you started the project OpenLLMetry. It's an open source project. Currently, actually, it's Apache 2.0, right?
Yes.
If I'm not mistaken, run by Traceloop. And do you want to give us a bit of background? What is OpenTelemetry? Give us the elevator pitch for OpenTelemetry.
So OpenTelemetry began as an effort by us to build the missing instrumentations for GenAI that were missing from OpenTelemetry. So we started by covering all the LLM vendors that are out there. We continued to vector databases and frameworks. And so now we support almost 40 different providers, vector databases and frameworks. And we've been collaborating with a couple of them. So, a couple of vector database owners are the co-maintainers of those instrumentations within OpenLLMetry. And we've been also collaborating with other observability platforms that wanted to support GenAI as well, namely Dynatrace, IBM, but also Google, Microsoft, and Amazon has been contributing code and supporting us through this journey. I think what's so we started with building those instrumentations, and quickly enough we realized that it's not just that we're missing those instrumentations from the OpenTelemetry project, but we're also missing the correct semantic conventions and the solutions to how to log everything that I mentioned before: images, big prompts, and so on and so forth. And so we've kind of defined our own set of semantic conventions. That was back in August 2023. With time, we've got in touch with the OpenTelemetry community, and we established the GenAI SIG. Was me and someone named Drew from Microsoft, and Ludmila from Microsoft back then. Now she's working at Grafana. And we began working on the GenAI SIG in an attempt to kind of standardize the semantic conventions that we've built with OpenLLMetry. And I think the main and so the goal for the OpenLLMetry project has become since then to be kind of the spearheading the OpenTelemetry research for GenAI, while we use like SIG as a platform for standardizing the work and the best practices that we've built as part of the OpenLLMetry open source.
So I think it's interesting. So it's sort of like two main parts to OpenLLMetry, as I see that. One is the tooling or the instrumentation part, and the other one is more of the the open protocol extension and the associated semantic conventions. Would that be right? And then obviously the latter became or is feeding into the SIG now that we have a special interest group dedicated to that.
And the last thing we added was an SDK, because we have the instrumentations. If you go to our open source, you will see in the packages the directory. There's like lots of different directories for each instrumentations, and these are all like separate Python packages, so you can just use them directly. But then also we have an SDK, because we realized that a lot of people who are coming from the AI world don't know how to use OpenTelemetry and don't care. So we want to make it easy for them to just install install our SDK, in one line, and then just use it. And then with time, we realized that there are a couple of kind of missing concepts in OpenTelemetry that we need for AI. And so, for example, we've built annotations, a couple of decorators on Python that you can put on top of functions that will kind of mark the entry point for certain AI flows. So, you're looking at agents, for example. So you want to mark, okay, this is an entry point for an agent, and these are entry points for different tools that the agent can call. You want to mark them in your code so that we can log them and kind of rebuild the trace for you. We don't have these in OpenTelemetry, we can start a span in OpenTelemetry with an annotation, but that's it. We don't have like a notion of an agent or a tool that you would need for AI. So we built them into the SDK. And then we realized that for AI observability, it's really, really important to log sessions because as opposed to kind of, again, classic observability, you don't just care about a single trace. There's another concept of a session, which is composed out of multiple traces. A session can be like a chat conversation you're having with a chatbot. You need to build another notion which is bigger than a trace that will kind of model this entire conversation that the user had with an AI bot. We have metrics that we want to log for these kind of sessions. And so we needed to kind of extend on the concepts that we have in OpenTelemetry to support the needs of people who are building AI systems.
Yeah, and I should say that the need for a session or whatever we will define, or flow or something like that is sort of the augmentation of several traces together is definitely something that I've heard in the community in the past years as well, also outside AI. So I think this is provides yet another motivation and maybe riding this hype to get more attention to addressing this specification, because you see that in other, even if you look at traditional web-based user interaction, human user interaction. If you think about that, I don't know, a login process to a website could be not just one invocation of user login and get the success. It could be a multi-stage where you do some sort of an authentication first, and maybe even you go out to a Google authentication or some other means of external, and then you come back, and then you go to the service. And each one of these is its own trace, maybe working with. So I think on the one hand, this is definitely need that I've seen arising in other use cases. Secondly, this I think becomes even more relevant when it comes to AI. So I hope this gets us, maybe this will be the incentive to get the community to address that across the board. And you mentioned the decorators and annotations. You mentioned that for Python, right? What programming languages are supported these days? Can you help share the
So we support, Python and TypeScript are the main languages we support. We have some beta support for Ruby and Go. And then we're also working on support for Java. And then we also built other ways to instrument your applications using OpenTelemetry that we realized that people will find useful. For example, we've recently released an OpenTelemetry first LLM gateway. It's called Hub. And the idea is that for some companies, it might make more sense to just use an LLM gateway that will sit between the LLM models and your kind of entire system. And this can kind of log standard OpenTelemetry spans for every request that's going through it. And so we've built that, and it's also kind of classic OpenTelemetry, all the semantic conventions and everything just out of the box. And
when you say classic OpenTelemetry, is that like an OpenTelemetry collector instance, or just to make sure?
No, it's written in Rust, and it uses the Rust SDK to output OpenTelemetry spans. Yeah, but then I mean it's standard OpenTelemetry using all the semantic conventions that we've built with OpenLLMetry and GenAI SIG. And we've also been thinking about other ways that the OpenTelemetry can benefit from GenAI. So for example, and this is super new, we just released it last week, we've built an MCP server for OpenTelemetry backends. So any OpenTelemetry backend can now use another open source, we built also Apache too, can use that, can connect to that MCP server, and then you can basically connect, let's say, Grafana to Cursor or Claude Code, which opens a whole set of possibilities on how can you kind of consume your production OpenTelemetry traces and metrics and logs in your development environment. And so we see kind of the way that GenAI technology is developing, there will be a lot of these integration points between OpenTelemetry and everything GenAI.
Makes sense. And MCP, that's hot news from last week. I guess you can say another KubeCon hot update. So
Yes.
that's great. And do you have for other, if you talk about these protocols, anything else that you have in the works or in the roadmap? I don't know, A2A or anything else in that regard?
Yeah, we've been also collaborating with with A2A, Google's A2A, and agency, which is now was founded by Cisco and now became part of the Linux Foundation, which is another agent-to-agent protocol. We've been collaborating with them all, and we have plans to kind of fully support them as part of OpenLLMetry, including propagating traces, IDs in the headers and everything that's needed. And we've been also working hard on supporting all the frameworks that are coming out. So you look at the space in the industry. At the beginning, LangChain was kind of the most prominent framework that everyone was talking about. Then came LangGraph, which kind of superseded LangChain. Llama Index was kind of like the main competitor. But in November 2025, we have many more frameworks that people are using and are becoming extremely popular. So there's Crew AI in Python, Mastra in TypeScript, and Agno in Python, just to name a few. And then also Google came out with their own agents framework, and Amazon came out with their own agents framework, and OpenAI came out with their own agents framework, and we support them all. And I say it, and it took a lot of time to make sure that we support everything with all the semantic conventions that we need. And like the domain and the market of agents framework today is huge, and it's like there's more
exploding.
agents framework than people building with agents.
Yeah, that's true. That's a lot happening there, and keeping track of these is a significant effort. And also, I think coming also wearing my hat from the foundation hat, both in the LF and the Linux Foundation, the CNCF, you see that there's first of all a journey to make these foundational and not vendor led, and secondly to try and get the gather influencers and companies around that. And I assume that this will ultimately get to a convergence process. So we've seen that in the industry and many other things. You get the divergence, the diamond opening up and then the diamond closing on the divergence. We're now definitely on the divergence side. But good grasp for you. And I think if we talk also about that, they're the main vendors that provide the LLM vendors. You mentioned OpenAI that you sound like you work a lot with others like Anthropic and others. How does it work with them? Like you mentioned before that you don't get the level of visibility from that black box that is the back end of the LLMs, but what do you get? What kinds of observability do we get into the workings of these vendors? And maybe you have deeper integration with the ones other than over the others. Happy to hear more about that.
None. We literally don't get any visibility into what's happening within these models. It's unfortunate. I think part of the reason is that they don't want to kind of tell their secrets and how do they actually run these models behind the scenes, because today we know that these models are not just the neural networks that are powering them. We also have a lot of kind of engineering working behind the scenes to kind of route to the right model or run all those mixture of experts that we have since GPT-4. And so we know that this is much more complex than just a neural network, but we have no visibility on what's happening behind the scenes. Unless you're using one of the open source models. So for example, VLLM, it's a popular open source for running LLMs. We've built together with IBM instrumentation within VLLM for VLLM. So now if you're using VLLM, you can get full visibility into what's happening inside the server that is powering the LLM, which is super great. So if you're using your open source models, you get much more visibility into what's happening.
That's amazing. So, and then for the large one, the commercial ones, essentially, so you get the granularity you get is the call to Anthropic or the call to API. This is the granularity of what you can monitor, right? And you mentioned, I think, again, just to emphasize a lot around vector databases, right? Because these are, for those who don't know, these are the storage for the embeddings that are generated by the LLMs, the embedding models, and so on. So, can you tell us a bit more about what you do with the vector database space?
So again, vector databases, as you said, like we need them to for context engineering or for running RAG pipelines. So I want to send the right context to the model so that it will be able to answer the user's questions. So I'm storing kind of my whole corpus of data in a vector database, and then I'm fetching it whenever I need it. So we are logging
knowledge base essentially.
Yeah, kind of a knowledge base. And so we are logging everything that's coming in and out of the vector database. So, for example, the query and the content. So, what was the vector that we sent to the vector database? What were the vectors or the responses, the data that the vector database has outputted, along with the scores? Because, for example, looking at the scores, so maybe 2 sentences on vector databases, the way they work is that they use semantic similarities to fetch the most relevant texts to the query that you send them. So the way they do it is that they have some scoring mechanism. Sometimes it's just a vector search, sometimes something else. And then when they return the responses, they usually attach a score to each response. So we log that as well. So it can be used to kind of detect how well your vector database is performing. If you get low scores, then you might need to tweak. Maybe you're missing some data in your vector database for the queries that your users are asking, maybe something else. So we also do that.
Sounds good. And I think in terms of when you look at your goals, so you mentioned a lot. You've been doing a lot in the integration space and everything. And actually, some of these came hot off the press. I think some of the integrations that you mentioned with new frameworks and so on. So all of that is really, really new. Really happy to see that coming out. What do you have on the roadmap? Well, on the OpenLLMetry roadmap?
So I would say, so now the OpenTelemetry is not just OpenTelemetry, right? It's OpenTelemetry plus Hub plus the MCP server. So we want to continue building and investing time in all three of them. And for us, number one priority is keeping up with the industry. And specifically for GenAI, I hope it will slow down in 2026. I don't know, let's see. But so far, everything is moving fast. There's a new framework every other day, new models, new capabilities that we want to support. And so we want to keep up with the industry. This is like our number one priority. How can we make sure that we're supporting everything, every new advancement that we see in the GenAI world or domain? And then B, we want to kind of make all the tooling, all the OpenTelemetry native tooling that we've built work well and be as feature rich as expected and be as useful to people. So, take the LLM gateway as an example. There's a lot of features we want to build into an LLM gateway that we want to build, and we're building this year and next year. If you think about an MCP server, there's a lot of complexities into, okay, how do you make an MCP server useful for the coding agent that is using it? So the more we get users, we just released it last week, the more users we get to use this MCP server, the more we understand what kind of tools do we need to expose so that Claude Code can actually use and fetch the right logs and be able to solve production bugs more easily, for example, or like investigate and do root cause analysis for outages.
Yeah, and that's a good opportunity maybe to tell our audience where can they see all these great stuff, where they can check them out, and maybe even chime in on the discussion, get involved on OpenLLM.
Yes, so everything is on GitHub. So github.com/Traceloop, you'll find all the open source. The main one is OpenLLMetry, so you can also go just directly there. Is github.com/Traceloop/OpenLLMetry. And then the other ones are also part of the organization. We divided them into different languages. So you have OpenLLMetry-JS or Go-OpenLLMetry or OpenLLMetry-Ruby. And then separate from that, we have the Hub, which is the LLM gateway, and OpenTelemetry MCP, which is the OpenTelemetry MCP server.
And is there a place for people to chime in on discussions,
yes.
chat, Slacks, and other means of communication beyond the GitHub?
Yes, we have the OpenLLMetry Traceloop community, which I welcome everyone to join. If you want to kind of contribute code, you're welcome. I'm always there. If you go there, you will see how many kind of answers I'm answering to our community members. You can easily join at traceloop.com/Slack. So we are on Slack. And you can also find it if you go to the open source. There's a link there. And we love contributions. I said it here, but I always like saying that everything is moving so fast, and just making sure that we support every new development in every. So imagine you have 40 different models, vector databases, and languages and frameworks we support across multiple languages. It's not easy to always make sure that we support the most up-to-date SDK, the most up-to-date, I don't know, API changes that these providers are making all the time. And so we love contributions, and we try to make the process as painless as possible. We have tests that are making sure that we don't break existing behaviors for our users. And as long as the test pass and lint pass, I will make sure to kind of merge any PR and release new versions as fast as possible.
Amazing. And, wearing my CNCF ambassador hat, obviously, and talking about OpenTelemetry, the natural question would be, is this project that is currently hosted by Traceloop, there's intentions to make it part of the CNCF and specifically part of the OpenTelemetry project? I know the short answer is yes, there is an intention, but do you want to update the audience where things stand?
Yes, there's an intention. I think it takes a bit more time to actually do that, because there's a difference in speed. OpenTelemetry as a project that is much more mature than OpenTelemetry moves slow, because there's a lot of constraints around OpenTelemetry, and OpenTelemetry needs to be able to move fast because it operates in an industry that moves much faster than like the classical observability industry. And so we are working on merging it upstream, but at the same time, we are still working on OpenTelemetry, because we want, for us, number one priority is to match and to be and support everything that is available on the GenAI industry.
Makes sense. And talking about again on the CNCF side and OpenTelemetry side, we talked about the OpenTelemetry LLM semantic conventions SIG. So it's been, just as a background, it's been like OTel had a suggested goal to introduce semantic conventions for modern AI for some time, and I think this was the right way to plug it in. I think it's even started as like LLM. OTel LLM SemConf, right? The LLM observability semantic conventions, and then it was rebranded to as a generative AI observability, or OTel GenAI instrumentation. So, but it's essentially the same thing, right?
Right.
And so the SemConf is there. It's a semantic convention. It's there since you said April last year,
2024,
right?
yeah.
So it's already over a year now.
Yeah.
A year and a half ago. And there's already, again, for the audience, the SIG means that you have a project board that you can see what's been worked on. You have meetings, regular meetings. You have the Slack channel. So maybe you can give a bit of a background about just for people who want to chime in and follow the SIG and maybe even join.
Yes. So there's the CNCF Slack workspace that everyone can join, and if you search at Google for the OpenTelemetry GenAI SIG, you will find all the meeting summaries. So everything is public. I think this is what I love about OpenTelemetry. You can easily, people ask me sometimes, how can I join the OpenTelemetry SIG? You can join. Just search online. You will find all the documentation. If you go to the OpenTelemetry community repo, so it's github.com/OpenTelemetry/community, you will find all the information there. Everything is public. All the meeting summaries are documented there. There's a Google Doc that we keep up to date with all the meeting summaries, and there's a Zoom link you can join. It's Tuesday at 7 p.m. Israel time, which is 9 a.m. Pacific. So you can join the meetings. It's every week. We also do every other week kind of APAC friendly meetings, which will be at, I think, 7 a.m. Israel, which is 9 p.m. Pacific, for like people who are in East Asia. So we really want to have everyone from no matter where we are in the world to join the SIG and influence the decisions on how should we kind of instrument GenAI based applications.
And who's just to get a sense, you mentioned a few names before, but who's on the SemConf SIG, who is involved these days, just for people to get a sense?
So it's actually it really quickly enough became one of the largest SIGs in OpenTelemetry, in my opinion. We have currently we have there folks from Grafana, Microsoft, Google, and also other GenAI observability startups. Arise and Pydantic AI, and we have really people from all across the industry joining on a weekly basis, discussing how to do AI observability, which is really cool if you think about it.
Yeah, for sure. And the output, just for people to understand. So what's if you summarize the mission statement, what the outputs, the collaterals, the deliverables, sorry, that it's supposed to be producing?
So we want to define all the semantic conventions that we need. And we also want to work on the implementations for all the instrumentations. So as we have a lot of them in OpenLLMetry, we want to figure out ways where we can eventually either merge them upstream or keep them within the OpenLLMetry repo and kind of standardize them there.
Okay, sounds good. And for those who don't know the semantic conventions, I know it's a bit abstract for many who are not involved with that. But ultimately, once semantic conventions are stabilized, they're then baked into and then they're stamped. Then each and every one of the SDKs and the agent, auto instrumentation agents and whatnot will then it will sort of cascade down, and they will support that. So once, and I'm also a lead, for example, in the CI/CD semantic conventions and in the service and the resource metadata. So and deployment metadata. So I'm saying all of these, it doesn't matter which aspect of the system it is. Once the semantic conventions are there, then they're being propagated into all the implementation side, both on the pipelines, on the auto collector, both on the generation side of the telemetry with SDKs and agents and whatnot. And then you get it out of the box. That's essentially the beauty of it. So for those who are less familiar with the semantic conventions, because for many people, it sounds like, yeah, it's very abstract. What do I care about it? You care about it because once it's stabilized, you get it out of the box. And the other part where you should care about it is then when it's not yet stabilized, you can influence it. You can get involved there. Exactly. If you have a passion into the topic, please join Nir, join the community, join the calls, or join the Slack channel for the async part of the discussion, and help us shape these semantic conventions in a way that will best describe and enable your own workflows and your own applications.
Yes, exactly. I think semantic conventions, it's kind of, sometimes it's hard to understand, because at the end of the day, the output is a const in Python. You have like a const which says, okay, what is the name when I'm creating a span for an LLM call? What is the name of the attribute of the request, if the model requested? Okay, this is like an example of a semantic convention.
And the type, and if it's an enum, then the values,
and so
exactly.
The reason it's important, okay, so first you can think, okay, why would I want to influence it? And the reason you want to influence it is because if you have something that is important for you you want this to get logged, then you want to go and come to this meeting and say, hey, I want to log the service level agreement that I'm sending to OpenAI. This is like really specific to OpenAI, but I want this logged because it's really important for me. Okay, come to the semantic conventions and bring, and tell us about why is it important, and then we can add it to semantic conventions, which means that every OpenAI instrumentation will automatically log that. The good thing is that once this is stabilized, all the backends can use it and can rely on this information to do all sorts of things to help you monitor your systems better. So if everyone knows that the requested model is in request.model.model, then they can use this information to build automatic dashboards for you and to kind of surface information more easily. If, on the other hand, each instrumentation logs this data in different attribute, then the backends can't really use this information and produce all these kind of nice tooling on top of it. So this is why it's really, really important. And this is why once it's stabilized, all the users can get a lot from that.
I think you explained it beautifully. And maybe one last question before we move on to the last part. Where can people actually follow you, Nir, and maybe get in touch with you after the episode?
So first of all, I'm available on LinkedIn. You just search for my name on LinkedIn, and then you can also find me on Twitter. I'm fairly active there. It's Nir_GA. I'm also active on TikTok, even though I'm not Gen Z myself, but I started. I'm uploading these videos on LinkedIn for a while, talking about AI, Gen AI, observability, and everything. And at some point, someone told me, "Yeah, you should just upload it on TikTok as well. Maybe it will work," and it worked. So now I'm a TikTok influencer as well. So you can also follow me on LinkedIn, on Twitter, on TikTok. It's as well Nir_GA. I think I'm like, people send me emails. You can reach out to me even on my kind of work email, nir@traceloop.com. People sometimes ping me. They say like, "Hey, can you talk to me? Can you walk me through the open source project? I want to contribute." And I say, "Sure, yeah, like let's go on a kind of a 30-minute Zoom call. I will walk you through the project. I will help you set it up so you can kind of contribute code." So if anyone wants my help, feel free to ping me. I will just send you my Calendly and we can book some time.
Sounds good. And also, of course, on the show notes, I will put some references for to follow up with Neil. And with that, I'd like to switch to a few quick breaking news. Neil, please stay with me. I'm sure that you will probably have some interesting insights on that as well. Hot from KubeCon, beyond all the goodies that came with OpenLLMetry's releases and the SIG. I guess that I will at least focus on the graduated projects. I think Knative has graduated. It's for those who don't know, a middleware for deploying, managing modern serverless workloads on Kubernetes that takes care of all the auto-scaling, routing, event delivery, all of that stuff. So I think this is a major milestone for a project that has been around for quite some time. Actually, we recently had an episode here on the show about Kada, which is another CNCF project in the space. I'll share the link for that on the show notes as well. So kudos to all the maintainers bringing Knative to graduation, to maturity. And a few on these also CrossPlane project reached graduation under the CNCF. Really nice stats, like over 3,000 contributors from more than 450 organizations. Really impressive momentum around CrossPlane. Top 10 of all the CNCF projects for contributor engagement and authorship. So really nice, and it nicely aligns with the V2 major release that CrossPlane just had, I think 3 months ago, if I remember. That I think the most notable was the composition, how you can now include any Kubernetes resource, not just the CrossPlane managed infrastructure, and the vast integration, just like in that we talked here. The integration is key. So having integration with the Kubernetes and Helm and Argo and Flux and OPA, Prometheus, Backstage, whatnot. This is also, again, a very clear sign of the maturity of the project. We also had graduation of Dragonfly and in-toto. To be honest, I have less experience directly with them to comment on them. But maybe, Nir, do you have any insights on any of these, or your thoughts on the graduation of these projects?
I think it's great to hear that these project graduation. I think like I love the CNCF kind of community, and I think you're looking at like these organizations that are helping the open source community prosper. I think thinking about OpenTelemetry. So I think CNCF is clearly becoming like the top organization and the place where you want to be working on open source projects.
Yeah, definitely. And maybe the last note is that we at the CNCF, we just released a report with /data about the state of cloud native development. Also interesting to see. I propose the momentum. I think one of the more interesting stats that I've seen, I've been preaching that finally I have the quantitative measure, is that it's not just for DevOps. It started from there, and people think Kubernetes and Prometheus and whatnot. But actually, 77% of backend developers reporting using at least one cloud-native technology. So this is to demystify this thing that no, it's primarily DevOps. I think it was very nice to see 77%. And we see also growing uses, hybrid cloud usage, risen from 2 to 32%, so almost a third across all developers use a hybrid cloud model, also very interesting, and also multi-cloud deployments getting to 26%, again, over a quarter now. So really nice to see, because we all talked about Kubernetes being sort of a common language in a way that abstracts across. It doesn't matter which infrastructure you use. Here you can really see that in action as part of that. So check out the stats. I'll share obviously the links there on the survey and the results there, the state of cloud native development. That's all we had for today's episode. We're on time. So Nir, thank you again so much for joining me on this episode.
Thank you very much.
Great, and I'd like to obviously thank all the listeners and the viewers for the episode. As always, all the episodes are available on your favorite podcast app or on YouTube. So just check out Open Observability Talks, and you'll find it. You can also follow us on Blue Sky, on LinkedIn, on X, at OpenObserve to stay up to date about these topics, about the episodes. Sometimes we do also live streams, so maybe you can catch these live streams and just carry on the conversation. I'm Dotan Horovits. Thank you very much for listening, and see you on next month's episode. And until then, may the open source be with you.